Hey, this is Chris Plush from CG Masters, and in this tutorial I'll introduce you to how you can use Python in Blender to read a list of values from a file and automatically generate a bar graph with them. And even if you have no purpose for bar graphs, there's still a lot to learn about scripting here. You don't even need any Python experience to follow along either. I'll be explaining the code we write in detail and you'll see every step. Though keep in mind, I won't be going over all of the absolute fundamentals of programming in this, but if you like this tutorial, let me know and maybe I'll make some more programming stuff. So in this tutorial, we'll be reading CSV files, which stands for comma separated values. Here's what a CSV file looks like in Excel. This is all just the amount of precipitation each month for where I live. We're going to make a bar graph out of it. You can see each row has a set of values separated into two columns. The script we'll be writing will be able to read data like this, but it'll also be able to read simple text files like this one here, where there are actual commas separating values, but still one set of values per line. So this script can read multiple formats like that, which is handy. Now first, make sure to download the resource files for this tutorial. Then open up Blender and let's clear the scene by pressing A to select everything, then press X and delete it. Now let me press numpad 7 for top view because this is the view new objects will be added in from. And now let me split the window. So I'm going to go up to the top right corner of the 3D view, click there and drag to the left. Now let's go into the editor drop-down menu and we'll switch this side over to the text editor. And let's split this window as well. So let's go to the top right corner, click there and drag down. And let's click on this editor down here and we'll change this to the info editor. This editor will come in handy in helping us figure out which Python commands to use, because everything you do in Blender gets listed in this window right here in its Python format. For example, if I press Shift and A over here and I add in a mesh plane, you can see there's the code, there's the Python script there for adding in a mesh plane. So we can actually use this in a script now if we wanted the script to add a plane. Let me get rid of that. But for right now, let's just drag that down so it's minimized. And let's add a new script in. So up here in the text editor, I'll click on New, and it creates a new text file for us. And let's rename this text file to Graph Generator. Now for our first line of code at the top here, let's type in import CSV, all lowercase, because case matters with programming. This line of code imports a module for reading and writing CSV files. You can think of modules like add-ons. They contain extra functions for the programming language that aren't available by default, so you need to load them in first before you can use them. So at the top here is where we'll import all the modules that we need throughout the script. So let me press enter twice to skip a line. And actually, before we move on, I'm going to click on that little arrow right there to bring up the right side menu. And I'm going to increase the font size so that you guys can see the script that I'm writing a little bit better. And I'll just drag that over to close it, and that's a little bit better. And now on this line, enter this line of text. So this line here opens up the CSV file so it can be read. And wherever you save the resource file for the tutorial, type in that path right here in single quotes. And be careful with the slashes too. They should be forward slashes because backslashes are reserved for something else in Python. Now there are other ways to open up a file, but they leave the file open until you use another line of code to close it once you're finished reading it. But using the with statement here, we'll open up this file and store this as the variable f, and then it will close that file that we were reading from. So now the variable f has all the same data that was in this CSV file. Then at the end of the line here, we place a colon to let Python know that whatever lines are next are part of this with statement. Because of this colon, when I press the enter key to go down to the next line, it's going to indent that line. And that simple indent right there lets Python know that whatever code follows is part of this with statement right here. So now let's type in another line of code. So what we need to do is sort through the data in F and make a list of values from it. And that's what this line does right here. In this line, we're creating a list called readout. And within this list, we have the reader function from the CSV module reading all of the data in the F variable. Now all the data in the F variable is in CSV format. So this CSV reader is sorting through all that data and creating a list of values from it. And it'll be more clear once we actually see that list. So let's press enter to go to the next line and let's type in this. Type in print parentheses readout end parentheses. So this line is going to print whatever is in parentheses, which is our readout list. Now in order to print that out, we need to run the script, and for that you can either press Alt and P, or you can click on the play button up here and run the script. So do that, and in order to see that print, we need to look at the system console. So let's go up to the window menu and toggle the system console. And there we go. Here's our list. Here's our readout list right here. In this window, we can see things like Python errors or whatever we print from a Python script, which is really handy. So any number of items inside brackets is called a list in Python. And you can even store smaller lists inside of a bigger list. For example, our readout list has a bracket to start it off here and a bracket to end it. And within these brackets of this list, we have all these other lists. And each one of these lists is the two values from each line in the CSV file. For example, you can see brackets around January and 3.52. That is one list right there. And then a comma, and then we have the next list, and so on. So we have 12 smaller lists inside the big readout list. So that's how that CSV reader organized all of that CSV data for us. So let me click back to Blender and let me erase that line. And make sure to backspace all the way back to the beginning and get rid of that indent, because we're actually done reading the file now and we want to start a totally separate block of code. So let me press Enter again to skip another line. Now the readout list has 12 lists in it, and I want to be able to automatically go through one list, generate a bar for it, and then automatically go through the next list, generate a bar for that, and so on, until there's no longer any lists left to go through. For that, we'll use a for loop. So let's type this line in now. Type in for a in readout, colon. Now this line will read through every item in the readout list, one item at a time, and it assigns that item to the a variable. So for example, let me look at the console again. What it'll do is first take the first item in the list, which is this list containing January and 3.52, and it assigns this list to the variable a. Then we can do something with this information, like make a bar on the graph for it. And when we're done, then it moves on to the second item in the list, which is this list containing February and 2.74, and it performs the same actions on that item. And it does that until we run out of items in the list. So let's start by creating a new plain object for every item in the list to use as bars. In order to create new objects, we'll need the BPY module. So at the top of the script here, I'll press Enter to go down to the next line, and I'll type in import BPY. And now let's click at the end of the last line to place the cursor there, and I'll press Enter to go down to the next indented line. Again, the colon at the end of this line indents the next line to let Python know that this code will be part of the for loop. Now to figure out how to add a plane in through Python, what we can do is over in the 3D view, I'll press Shift and A, and I'll add a mesh plane. And now let's go down and drag this window up to see what the Python code is for adding in a plane. So I'll left click right there to select that code, and you can see there it is. We added in a primitive plane. So now what we can do is right click on that code and copy it, and then I'll go back up here, right click and paste it. There we go. Now we're missing some of the text over on the right side there, so let me just spread this area out a little bit by pulling these windows apart. And you can see after the add line right there, we have a set of parameters for the newly added plane in. We don't really need all of these parameters in there. We're just going to keep the size here, and I'm going to turn the size down to 1. So let me left click and select all of those parameters, and then I'll backspace to delete it. And then I'll change 2 to 1. So the plane will be added in at a size of 1 by 1. All the other parameters that were listed there were actually default for a plane. So by erasing them, it's just going to use the default anyway when we add a new plane in. And alright, so let me drag this down now. We're done with that window for the moment. Alright, so let me go over here now, and I'll press X and delete that plane. Now let's see if this actually works by running the script. It should create one new plane for every item in the readout list. So we should end up with 12 planes. So let's click on the play button to run the script. And there we go. You can see it created 1 by 1 planes. And if I press G to move them away, you can see we've got a bunch of them. In fact, we can see how many objects we have down here at the bottom. We can see we have 1 out of 12 selected. So it created 12 new planes for us. So alright, that's awesome. It's working so far. But now for each plane generated, we want to scale it based on the numbers in the lists. So we're going to scale these on the y-axis like that. So that's how we're going to make each bar in the graph a different height. But first we'll need to get access to this object that's added in. When a new object is added in, it's selected and active by default. So let me go over here and press enter to go down to the next indented line. And to get access to the active object, we can use this line. I'm going to type in new underscore bar equals bpy.context.object. So this line right here will give us access to the latest object added in, which is the active object. And we're assigning that to the variable new bar, just so it's easier to type if we have to type this over and over. Now, whenever a new plane is added in, its origin point is at the center, and that's where it's going to scale from. So for example, if I had a few bars like this, and I scaled them on the y-axis to different amounts, you can see that the bottoms of these are no longer aligned, and that's not good for a bar graph. So what we need to do is take all of these vertices and move them up 0.5 Blender units so that the origin is at the base of the bar. So now when we scale these on the y-axis, it's going to go just up and down, but the bottom of each bar remains in place, so everything remains aligned. So that's what we need to do. For every new plane added in, we need to move the vertices up 0.5 Blender units so the origin is at its base. And we'll use Python to move all the vertices up for each new plane. So now we're going to access some mesh data and move some vertices around. For that, we'll create another for loop. So at the end of this line, I'll press enter twice to skip a line but still remain indented there. And now let's type in this line. For vert in new underscore bar dot data dot vertices colon. The data.vertices part here will give us a list of vertices for the latest plane added in. So it'll be a list of 4 vertices. Then again, the for loop will go through the list one by one, and it'll assign a vertex to the variable vert. And then we can modify this vertex's position, and when the code is done with that vertex, it moves on to the next vertex in the list and modifies that position as well. And it'll do this until it runs out of vertices. So now let me click at the end of the line there after the colon, and then I'll press enter to go down to the next line, which will be indented. And now let's type this line in. Type in vert.co brackets 1 end brackets. Then skip a space and type in plus equals 0.5. So vert.co is the XYZ coordinates list for the vertex. We want to change the Y coordinates, so we type in 1 in brackets to call the second item in the coordinates list, which is the Y location. Make a note that lists start from 0. So the first item in a list, which would be X in this case, would be item 0. The second item, which is Y, would be item 1, and so on. Now, typing in plus equals here means that we're going to be adding 0.5 to whatever the Y location value was before. So now let me just delete everything, and we'll rerun the script. And there we go. All the planes were added in, and all of their vertices were moved up 0.5 units, so all of their origins are perfectly at their base. So now when we scale all of these up on the y-axis, all of the bases remain level. So that's good to go, but one other issue is that every plane is still being added in, overlapping each other. So let's work on spacing these out now, and to do that, we'll just move the vertices over a certain amount. Now I want to move each plane created to the right on the x-axis depending on which item in the list the plane belongs to. For example, for the first item in the list, the plane will stay still. So item number 1 moves 0 spaces. Then item 2 in the list will move 1 space, and item 3 in the list will move 2 spaces, and so on. So that's simple enough, but in order to know how many spaces to move over, we'll need to know which item in the list the loop is currently looking at. So how can we figure out which part of the readout list that the for loop is on? Well, let's create a new variable for this. So I'm going to put the cursor right there and press enter to create a new line at the top of this loop. And let's type this in. Type in placement equals readout.index parentheses a. So index is going to tell us where a is in the readout list. And remember that a is the current item that the for loop is looking at in the readout list. So if the for loop is looking at the third item in the list, for example, then the index for that third item will be 2. So placement will equal 2. And that's perfect because as I showed you with these planes, we would want the third item to move over 2 spaces. So let's test this out now. Let's go down to the vertex for loop right here, and I'll click there and then press enter to go down to another line. This time we want to move the vertices on the x-axis. So I'm going to type in vert.co brackets 0, and then I'll type in plus equals placement. So vert.co0 gets the first item in the vertex's coordinate list, which is the x location. So now we can add to the x location by using plus equals, and we're adding the placement variable to it. So now let me select and delete everything in the 3D view, and let's run the script. And there we go. Perfect. You can see all the planes moved over at the perfect amount. So now we have 12 planes all side by side. But what if we wanted to add a little bit of space between each of them? Let's create a new variable at the top of the script that we can change whenever we want to. So let me click right there, and I'll press enter twice to skip a line, and I'll type in bar underscore spacing equals 1.5. This will be the variable we use to space things out. I put it at the top just to be easier to access. Any variables you want to be able to change easily will be much easier to find if they're organized at the top of the script. So now let's go back down here and let's simply multiply placement by bar spacing. So I'll type in times bar underscore spacing. So this is going to multiply the original spacing by this new variable, and let's see if it worked out. Let me select everything and delete it and rerun the script. And there we go. Alright, so it works. Now, one cool thing about this is that we can create a customizable bar width as well, just by simply scaling everything on the x-axis. You can see because all of their origins are still at the center of the world, everything scales to the right. So we can create a new variable to adjust the bar width for further bar graph customizing. One little issue though is that the first plane's origin is still in the center of it. So when I scale on the x-axis, that doesn't just scale to the right, a little bit of it scales to the left as well. Now when I create the rest of the bar graph graphics, I want to create a vertical axis right here along the green line. So if I have some of these planes scaling to the left, it's going to overlap those other graphics. And it would just feel a lot more organized if everything's scaled directly to the right and not the left. So let me press Alt and S to clear the scale for them. And let's see what we need to do. So we want the origin to be at the bottom left of this plane. So we just need to move all the vertices to the right 0.5 blender units. So let's just go back to this line here where we're already moving vertices on the x-axis. And at the end of it, I'll type in plus 0.5. And let's press A to select everything, and I'll delete it. And let's rerun the script. And there we go. Perfect. So the origin's at the bottom left. So when I select everything, press S and then X. Perfect. So everything scales directly to the right. So now we can create a new variable to use for custom bar graph width. So let's go back up to the top of the script and add in a new custom variable. So I'll press enter to go down to a new line, and I'll type in bar underscore width equals 2. And now let's go down to this for loop right here. And let me click at the very end there. I'll press enter to go down to a new line, but we're done with this vertex loop here. So let me backspace to get rid of one of the indents. So now after we're done moving all the vertices to the right, now I want to scale from the origin point to the right or the left based on this bar width variable right there. So let me type this line in. I'll type in new underscore bar dot scale equals parentheses bar underscore width comma 1 comma 1 end parentheses. And in fact, let me click there and press enter again just to create a space between this for loop and this new line here. So here we're calling the scale attribute of the new bar object. And this scale is defined in parentheses here with an x, y, and z value. So we made the x scale here equal to the bar width variable up there. So every plane added in should be scaled twice to the right. So it should be twice the width that it is now. And let's see if that worked out. Let me press X to delete everything. And then I'll press play to run the script. And there we go. You can see each one of these planes is now 2 blocks on the grid there. And that's looking great. Let's just confirm that. Let's change the bar width to 4 and rerun the script. And there we go. Awesome. So everything is in place, and now we're ready to make the height of each bar the same as the numerical values in the CSV file. Now we've already got a line for scaling right here. So we just need to change this Y value in order to scale these bars up and down. So what do we need to put here to choose the right numerical value each time this loop runs on a new item in the readout list? Well, let's go down a couple of lines and let's sort this out before we mess with the scale. Let's write in the following code. I'll write in print parentheses A. So A again is whatever item in the readout list the for loop is currently on. So printing A is basically going to print out every item in the list one by one. So let's press the play button to run the script, and let me open up the system console again, and there we go. So there's the printout. So each time the for loop runs, it prints out each item in the list that it's running on. Now we don't need the whole list, we just want the numerical values, and the numerical value is the second item in each list, which has an index of 1. So all we need to do to get these numerical values is type in A brackets 1, which will call the second item in each of those lists. So now let's press the play button again to run the script again, and we'll check the console again. And there we go. So this time it only printed out the numerical values each time. So that's what we need to write in as the y value for the scaling. So let's go back to the script. I'll get rid of this line, and we'll replace the y value here with A brackets 1. So now let me delete everything to start fresh, and let's press the play button to run the script. And you can see we get an error in the Python script. So let me Alt-Tab over to the console, and let's see what that error is. So it's telling me that error is on line 19. So line 19 is our scale line. And the error is saying it expected a sequence of items of type float, not string. Now a float value is simply a number with decimal places, and strings are words. And if you take a look at our list up here, you can see that all of our numerical values are surrounded by quotations, which means they're actually treated as words and not numbers. So right now, by typing A1 in the scale line here, it's like we typed a word in there instead of a number for the Y scale. So all we need to do is convert this value to a float. And to do that, you simply type float in front of it, and then surround it by parentheses like that. So now it's going to convert this string value into a float value, so this will now be an official numeric value here. So let me select everything, press X and delete it, and let's try running this script again. And there we go. And let me redo this with the bar width back down to 1. Everything's a little bit too wide. And I'll rerun the script, and there we go. Awesome. So now each plane created matches the numerical values in the list. And to confirm this, let's go back to the console, and let's take March, for example, the third bar, 3.81. Well, let me select the third bar. I'll press the N key for the right side toolbar, and you can see its Y dimensions are 3.81. Perfect. All right, and that's it. We're done with the bars now. Now let's work on adding text objects underneath each bar that say what each bar represents. So let's go down to the bottom of this loop here. I'll press Enter twice to skip a line. And to find a code for adding a text object in, let's add a text object in. So I'll press Shift and A, and I'll add in a text object. And let me bring this window back up. And you can see the code we need is right down here. So let me left click on that to select it. I'll right click and copy it. And then up here, I'll press Control and V to paste it. And let me drag this back down for now. Now we don't really need these parameters and parentheses here. So I'm just going to select all of that and erase it so the parentheses are blank. So let's see if this works. Let me select everything and delete it. And let's run the script. And there we go. You can see it added in a text object for us, or actually 12. Now for this, I want the text objects to be running up and down, like that. And I want the text to be aligned to the right. So for example, I'll go over to the properties over here, and we'll change the alignment here from left to right. That way, no matter how long the text is, it's always going to be aligned at the base of each of the bars. And I also want this to be vertical aligned, or in other words, I want it to be centered over the origin point. That way I can center the origin under the center of each plane, and you can see how the text is offset. But if we change the vertical alignment here to center, then everything is nice and balanced. So let's start by changing the text alignment properties. So let's find out what code we need for that by dragging this window up. And you can see we have the alignment options here that we were already playing with. So if you didn't actually go over to the alignment options here, do that now, and just switch that one to right and this one to center, and we have the two lines that we need right here. So let me left click on that to select it, right click and copy it, and then here I'll go down to a new line and press Ctrl and V to paste it. And we'll do the same thing with the Y alignment. So what do these two lines of code mean? Well, we know that bpy.context.object gives us access to the active object. And since we just added a text object in here, the active object is now currently the latest text object that was added in. So now we can access that object's data. And from there, we change its align X attribute to right. And that's it. Then we also change its align Y attribute to center. So let's see if it works. Let me get rid of this window for now. I'll press A to select everything, X to delete it, and then press play to run the script. And there we go. So you can see the text object is now aligned to the right, and it's also centered with the origin point. Now we just need to rotate it and place it under each one of the bars. So let's get the code for the rotation by simply rotating the object 90 degrees. So I'll press R, and then I'll type in -90 and press enter. Now let me drag this window back up, scroll down to the bottom, and you can see our rotation script right here. So let me left click on that to select it, right click and copy it. Let's drag this down, and now here I'll press enter to go down to the next line, then press Ctrl and V to paste. So here's how we rotate the object, and then in parentheses here we have all of these parameters. We actually don't need all of these parameters. Oh, there's quite a few. Holy cow. So let me start out at the end there and drag that to the left, and I'll backspace everything except the rotation value right here. I think by default it rotates on the Z-axis, so I don't even think we need to specify a rotation axis. But let's find out by running the script. So let me select everything and delete it, and then I'll press the play button to run the script, and there we go, it almost worked. It just rotated it the wrong direction. So let me take out the minus sign there so it rotates a positive 1.5708, and I'll delete everything again and run the script again, and there we go, perfect. Now just as a side note, this rotation value here is in something called radians, so it's not degrees, but this amount of radians is almost exactly 90 degrees. And I say almost exactly because if I press the N key for the right side toolbar, you can see when I click on the Z rotation value here, it's actually 90.0002. There are ways to get a more precise 90 degrees, but it's not really necessary for this, so we're just going to ignore that. Alright, so next up I want to get the text spaced out correctly. I want to space the text out under each bar, like that, but I also want to add a little bit of space between the text and the bar here. For this, we'll translate the object, so let's get the code for that. So if you haven't already, select one of the text objects, press G, and just simply move it, and then confirm. Then let's go down into the info editor, and you can see our transform.translate script right here. So let me left click on that, right click and copy it. I'll close this down for the time being. Then I'll put the cursor there, press enter to go down to the next line, then press Ctrl and V to paste. Now we also have a huge set of parameters after the translate command right there as well. So let's clean this up. We want to keep the value here, which is this value in parentheses. So I'm going to click there and drag all the way to the right, and then backspace all of that. Make sure you don't backspace those parentheses at the end there. So now we just have this translate command here with this value set in there, which represents the X, Y, and Z values. And for right now, let's change each one of these values to 0. When all axes are set to 0, there's going to be no movement when the text is added in. So let's change this. Now I want to move each of the text objects down 0.5 units on the y-axis. So let's change the y value here to -0.5. And we'll space everything out the same amount that we did for the bar objects, which is, where's it at? Which is this amount right here on the x-axis. So I'm going to select all of that, press Ctrl and C to copy it, and then I'll replace this 0 value here by pressing Ctrl and V and pasting that in there as the new x value. And we'll leave 0 as the z-axis value because we don't want to move it on that axis. Alright, so let's test it out. Let me press A to select everything, delete it, and we'll rerun the script. And there we go. Awesome. So now we just need all the text to say the right things. So let's press enter to go down to a new line here, and let's type this in. I'll type in bpy.context.object.data.body equals A and then 0 in brackets. So this line accesses the data for the object, and from there we can access the body attribute so that we can change it. And we change it to A brackets 0. Remember that A is the current item in the readout list. So for example, the first item in the list is another list that has January and then a numerical value. We want January, which is the first item in the list, so we write A brackets 0 to get that first item. So now every time this loop adds a new text object in, it should be given the correct name, the correct month name. And let's test that out by deleting everything and rerunning the script. And there we go, it worked. Now this is all going to add in wherever we move the cursor around too. So for example, if I hold shift, right click up there to move the cursor and rerun the script, then the whole graph generates right where that cursor is. And after manually adding some elements in, here's the final graph. This can all be automated with the script too, but I think this tutorial ended up long enough, so I'm going to end it there. If you want to check out the materials I used to finish off this graphic, you can download the resources for the video. Now there's a ton of customizing that can be done to this to make it a really robust graph generator script. You can automate adding materials, you can customize the text, like text size and even font, and you could even automatically generate the axis and grid for it that could even be based on the maximum value that's in the CSV list. I think we covered a lot here, so you can play with things on your own now, but just to help you out, let's do one last thing. There are so many different commands and modules and functions in Python, and you can look these things up online, or you can use the info editor to get some code like we've done in this tutorial, but there's also a way that you can print the directory of something to see what options are available to use. For example, you can see to change the selected text object, we're calling the align x attribute here from the bpy.context.object.data line. So now what other attributes are available in the data that we can change? To find out, we can print this line. Let's go down 2 lines and I'll backspace out of the indent there, and I'll type in print parentheses dir parentheses bpy.context.object.data, and then I'll close both parentheses. So here we're printing out the directory of this data line. So it's going to tell us all the attributes and options we have available from that line. So let's run the script and let's go check out the console, and there we go. So within this selected object's data, here are all the different attributes that we can change. You can see we have align X up here, align Y, which we've used, and also body, but we can also do things like toggle font bold or font italic, or even do things like change the size or the shear. And these are all just the options for data. We can even go higher up this chain here and print out the directory for the main BPY module, for example. So I'll erase everything except BPY, and then press play to run the script, and let's check out the console again. Now you can see what all the main options are in this module, and each one of these options will likely have its own directory as well. So keep that directory line in mind when you want to explore Python modules to see what options you have. Alright, so I'm going to end this tutorial here, so I'll see you around.